Okay, so we're going to do 1, 2, and 3 of this page, and hopefully that'll help you with the rest of this first part of this unit. So, inertia. We already defined inertia. Inertia is just the tendency of an object to resist a change in its motion, to resist it. So when I think about this, I think if I have two cars. They're both broken down on the road. One weighs 2,000 pounds. The other weighs 1,000 pounds. Which one has the most inertia? Which one has the most? Which one's going to be the hardest to get moving? In other words, it resists a change in its motion the most. Probably the one that weighs 2,000 pounds, right? It's going to be the hardest to get moving, and that's inertia. The tendency of an object to resist a change. Now let's look at number 2. That directly ties into our answer to number 1. The amount of inertia possessed by an object is dependent solely upon its what? Well, that's going to be its mass. So the more mass an object has, the more inertia it has. The 2,000 pound car is going to be a lot harder to change its motion, in which case its motion would be 0. So it's going to be a lot harder to get moving than the 1,000 pound car, right? Awesome. Another thing to note is that mass, again, I said this before, but I'm going to say it again. Mass is independent of weight. Your weight can change. Think about it when you're on a scale and you want to weigh a little bit less, so you kind of put your fingertips on the counter and you push just a little bit so it makes you weigh less on the scale. Well, yeah, that can change your weight a little bit. And likewise, if you pull down, you can pull yourself into the scale and you weigh more, but that's never going to change your mass. You're still going to have the same amount of elements in your body, whether you push on the scale, pull on the scale, whatever. Just like if I was to go to Jupiter, and maybe I weigh 100 pounds now, but on Jupiter I weigh 300 pounds, well, that's because Jupiter's pulling down on me more, like if I was to pull myself on that scale, right? But the molecules in my body, that's not going to change. That will have no effect on that. It'll just affect my weight. So that's important to keep that in mind. So no matter where you're at in the universe, your weight will be the same, but your mass will be the same, but your weight can change because your weight is dependent on gravity, right? So let's look at number 3. 2 bricks are resting on the edge of a table. Shirley, she short, stands on her shoes and spots 2 bricks. Wow, that was hard to say. She acquires an intense desire to know which of the 2 bricks are most massive. Since she is vertically challenged, she is unable to reach high enough and lift the bricks. She can, however, reach high enough to give the bricks a push. Discuss how the process of pushing the grips will allow Shirley to determine which of the 2 bricks is most massive. Okay, so she's trying to find out which brick has the most mass. She can't lift them up. What she can do is push them. And what we know is inertia, which is directly related to mass, is the tendency of an object to resist a change. So the more it resists that change, the more it resists that initial movement, the more mass it has. So going back to number 3, what difference will Shirley observe, and how can this observation lead to the necessary conclusion? Well, if she's pushing the brick, she can't pick them up, but what she can do is push the brick. And if she pushes them with the same amount of force, the brick that moves more slowly is going to have more mass. Or the brick that moves more easily will have less mass and less inertia, right? So if it doesn't move easily, it has more inertia and more mass. So hopefully that makes sense. It's not too terribly difficult of a concept, but just remember, inertia, it means more resist to change, and the more mass, the more inertia.